For the next video, I will discuss the data encapsulation. For the sending and receiving data from a source device to the destination device is possible with the help of networking protocols. When data encapsulation is used, the data is encapsulated with protocol information at each OSI reference model layer when a host transmits data to another device across a network. Each layer communicates with its neighbor layer on the destination. Each layer uses protocol data units or the PDUs to communicate and exchange information. For the protocol data unit or the PDU, it contains the control information attached to the data at each layer. The information is attached to the data field's header but can also be at the end of the data field or trailer. PDUs are encapsulated by attaching them to the data of each OSI reference model. Then each protocol data unit has a name depending on the information each header has. Only the neighbor layer on the destination reads the PU information, which is then stripped off and the data handed to the next layer. For the OSI layer model and PDUs, the 7-layered open system interconnection or the OSI layered model is basically defined for reducing the complexity of the internet working. The OSI model is then divided into two segments for more ease: upper layers and data flow layers. The 7th and 5th layer of the OSI reference model are application layers, also known as the upper layers. The upper layers are directly related to the user interface, while the OSI model's 4th, 3rd, 2nd, and 1st layer are also called data flow layers because they are related to the data flow. Each data flow layer has a protocol data unit, and each data flow layer's protocol data unit is defined as follows. We have the transport layer. Segment is the PD of the transport layer. Network layer, packet is PD of the transport layer. Data link layer, frame is the PD of the transport layer, and then physical layer, bit is the PD of the transport layer. For the encapsulation, the data encapsulation process is defined as below. We have the Tcp Header Encapsulation. The application layers user data is converted for transmission on the network. The data streams is then handed down to the transport layer, which sets up a virtual circuit to the destination. Then the data stream is then broken up and a transport layer header called a segment is created. The header control information is attached to the data field's transport layer header, and each segment is sequenced so the data stream can be put back together on the destination exactly as transmitted. IP header encapsulation. Each segment is then handed to the network layer for logical addressing and routing through a routed protocol. For example, IP or the IPX, Apple, Talk, DECnet, etc. The network layer protocol adds a header to the segment handed down to the data link layer. For MAC header encapsulation, the data link layer receives the packets from the network layer and places them on the network medium such as a cable or wireless medium. The data link layer encapsulates each packet in a frame, and the MAC header carries the source MAC address and destination MAC address. If the device is on a different network, then the frame is sent to a router to the routed through an inter-network. Physical layer encapsulation. Once the frame gets to the destination network, a new frame is used to get the packet to the destination host. To put his frame on the network, it must first be put into a digital signal. Since a frame is really a logical group of first and OS, the OSI model's physical layer is responsible for encapsulating these digits into a digital signal which divides on the same local network grid. So again, we have different kinds of encapsulation. First, physical layer encapsulation, MAC header encapsulation, IP header encapsulation, then the TCP header encapsulation.